Hello, good evening. Can you hear me? Hello. Can you hear me? Yeah.
Yes, I can hear you.
Yeah. I hope everything is good from all of you. Okay. And I hope already all of you get the previous materials, mainly slide or practice code, and also complete some work. Okay. So I'll just check your paper which you send me. Okay. So just simply add the abstract. Okay. I think yeah, you also need to add some other part which is not completed yet. So step by step you try to add. Then I hope it will be more better and we can easily publish it more scientific journal, inshallah. No problem. Okay. Okay, so let me share my screen. Okay, can you see my screen?
Yes. Right.
Okay, thank you. So today's we're gonna discuss about that basically three topic I try to cover. So first topic we try to discuss about that correlation analysis. So how we can easily make the correlation different types of parameter. Suppose NDVI and precipitation correlation, or NDVI or land surface temperature correlation. Okay, as well as how we can easily make the land surface temperature prediction. We also discuss about that, how to make the predict the land use land cover prediction using machine learning method. And another topic we will also discuss about that land use land cover classification using machine learning. Okay, so I hope already completed my 7 days training program, all of you already completed. So in this case we try to discuss about only for the built-in function, only for the built-in Google Earth Engine model. Okay, so Google Earth Engine provides some built-in model. Suppose classifier, smile random forest, or decision tree. So this type of built-in model we try to use in Google Earth Engine, and we just make the classification. But we can also use the different types of Python library. Suppose scikit-learn or linear regression model. So different types of Python package or module we also use, and further we can also make the more better classification. So this thing I also try to show you that step by step. Then I hope you can easily use this technique and make the any classification. Okay, any complex classification, it provide you the more better accuracy or better land use land cover mapping we can generate by help of different types of Python package. Okay, then you can easily get the more better idea. So let's go. I'll try to explain all of this step by step. Then you can easily get the idea. So let me share step by step. Okay, so I discussed the later. First of all, I try to discuss about the correlation, how we can easily make the correlation. So we can also check this theoretical part from this website. So they are very good. Explain all of those more better. So basically, what is correlation and how to calculate the correlation, mainly statistical part it's covered. So you can see this is the equation about the correlation. If the correlation value is negative, then what is that? So basically, you can see negative value indicated that perfect negative correlation. Okay, and zero indicate the no linear correlation between the variables. Okay, basically we try to make the correlation between two variable. Okay, it can be any two variable. You can just simply apply the correlation. Okay, suppose NDVI or LST, or NDVI or precipitation or LST. So different types of correlation we can easily do using this correlation technique. So if you check, this is the formula about the correlation. It's called the Pearson correlation. Okay, and we find out the you can see if the R value equal to negative, indicate the perfect negative correlation. If the R value is the 0, indicating about the non-linear equation, or there is no correlation. So this type of things we can also get. Also R indicate the perfect positive correlation, and you can also check the chart from here. So this is the chart. This chart indicating about the positive correlation. It's no correlation, mainly zero correlation, and this is the negative correlation. So any two variable, it can be NDVI-LST or it can be your precipitation NDVI, anything. We can just apply the correlation and then we can check, okay, positive correlation or negative correlation or zero correlation between the two variable using the Pearson correlation. So it's called the Pearson correlation. So you use the different types of correlation, not called the Pearson. So you can see this is the numerical example how to apply the correlation with the help of uh, um, Python programming language or Python package NumPy, and they are make the correlation. So you can see the correlation coefficient they are computed. But now this same technique we try to apply in our geospatial dataset. Geospatial dataset mainly NDVI or LST or any other dataset, geospatial dataset, mainly raster data we try to use. There are a lot of uses. You can see environmental analysis. Okay, so we try how to better environmental policy, understanding by the various environment factor. Okay, also you can see the weather forecast, different types of use about the correlation. You also try to read this full article, then you can get a lot of theoretical part about the correlation. So now let's take the practical example. I will show you that how we can easily apply the correlation analysis between any two variable, not only for the NDVI or LST, any variable, just apply the same process all time. Okay, then we can easily generate the correlation. So just open a new code editor. Okay, so first of all, we simply define our study area. So suppose I want to work with one place, so just I simply search here US. I just take the international country boundary polygon. You can put any country boundary polygon or any study area or any shapefile boundary and put the variable name, suppose AOI, and then call the table. This table I want to filter earth engine dot filter dot equal. Suppose I choose a country NA. Suppose I choose for Saudi Arabia. So this is my study area, or we can choose any study area to make the correlation for any two between two variable. I want to display the result, so just use your map.layer to display this AOI, and also focus on my given study area. Just use your map.center object. Object is AOI, zoom level suppose 10, and run the code. So now directly focus my given study area. So for this study area, I want to make the correlation. Suppose I want to make the correlation between two variable, suppose vegetation and temperature, mainly LST or NDVI and LST. Okay, between two variable, then I want to check what types of correlation we find out between the NDVI and LST. So normally we can understand about that any place had the lot of vegetation, that the low temperature place. Okay, so if we find out this type of negative correlation, if NDVI value is high, then LST value is low, or if LST value is high, then NDVI value is low. Mainly negative correlation we find out. But now we try to use just we make the analysis and check the result. Okay, for my study area. So let's go try to check it. So first of all, we need to generate the two variable NDVI and LST for this study area. So now we can apply the lot of way for calculating the NDVI or LST. Okay, we already know about that. We can easily use the different types of satellite imagery or sensor. Suppose you can use here the Landsat, or you can also use here the suppose MODIS. Okay, to generate LST or NDVI. Okay, using the MODIS or LST. So same process. So in this case, I try to show you for the MODIS satellite. So then I also give you an assignment for regarding Landsat. Okay, so I will show you the example using the MODIS, how we can easily use the NDVI and LST help of MODIS satellite data and then make the correlation. But you also try using the Landsat data for your own study area, because Landsat is very good resolution than MODIS. So we can easily apply this Landsat data any small study area. Okay, we can get the more better result. But for big study area, MODIS is also okay, no problem. Okay, so now we simply import our data set. We already know about that MODIS provide the ready-made data. Just I simply call from here. Suppose MODIS NDVI. I want to use suppose Terra vegetation indices. So this data I want to use. Okay, I want to use this data. So this is the data. Okay, so just copy the snippet ID from here and then paste. So in this case, you can also try after this class, you also try using the Landsat data, because Landsat is, we find out the more better resolution than MODIS. But in this example, I will show you for the MODIS. Okay, you try later using the Landsat satellite data, what happened. So take a variable. Suppose I put the variable name is NDVI collection. Okay, so now from here I simply filtered this data. So simply select one data, its band name, suppose NDVI, and this data I need only for my study area. Just use the filter bounce function with your AOY, and then put the filter date. I choose suppose 1 year data. I try to check 2020 January, 1st January from year of 2020 December 31. So this is my time period. Okay, so now I simply take the data set, mainly NDVI collection. If you check how many images have, just try to check NDVI collection and use the size function. Now it displays the result how many images are available for the NDVI. So we found the 23 images. So same process we also apply for MODIS. So now we take the MODIS collection. So simply search here MODIS LST. So and we use this data. Copy this snippet ID. And now take a variable. Suppose I put the variable name is LST collection. Okay. So now simply filter. First of all, select this band name. Band name is LSTD 1 kilometer. And put at the filter bounce with the study area AOI. Then put at the filter date. Basically I put the same date, 2020 01 2020 December 30. So now let's check how many images are available in this collection. Just take copy and use the size function and run the code. So we want the 46 images collection. So now we take for the 1 year data for the NDVI and LST. But this data set we also need to reproject the scale value, because if you check this data set have a scale. If you check this data have a scale. First I can see 0.02. So this is the scale for the LST data, and same we also find out that another scale for the MODIS NDVI 0.001. So these two scale we need to use to get the proper pixel value of NDVI and LST. Otherwise it shows a very large value, mainly digital number we find out. So this digital number we need to convert into reflectance value, NDVI reflectance value and LST reflectance value. So let's go try to just reproject the NDVI and LST. So just simply convert NDVI scale factor. Basically this scale factor is 0.0001, and also LST scale factor, which is 0.02. Okay, and I need suppose degree Celsius. Just simply subtract 273.15. So when I subtract this value from the Kelvin result, then we find out the result for degree Celsius. So now simply do it. You just create a function. Suppose I take a variable name NDVI and call just create a function. Okay, create a function. Element name, suppose I put the image. So now just I call the return this element multiply with the scale factor 0.001. So I hope you already know about this type of process. So that's I simply write the code without spelling, because in the beginner session we already discussed about this type of topic, how to reproject the scale factor, how to multiply, how to create the function. Okay, just I simply skip this type of part and show you the result. Okay, so then I apply the copy properties function, copy properties, and then call the element and apply it from system time start to system time end. Okay, so now this is the function. So this function we to connect with our collection. So this is the NDVI collection, just I call and connecting using the map function. Just use here the dot map bracket start and close the bracket. Okay, so now all of images simply multiply with the scale factor. Same process for the LST collection also, multiply 0.002 and subtract this value to get the result in degree Celsius. So take a variable, same process, I put the variable name suppose LST and create a function, same process, and put the elements of img, and then we simply put the curly bracket start and end, and then put our argument. So our argument is that we want to return this element multiply with scale factor 0.02 and also subtract this value 273.15, convert Kelvin to degree Celsius, and the same things apply all of images. So just put the copy properties, apply this element system time start to system time end. End. So now this is a function. Okay, just I call the collection. So this is my collection. Just I copy and connecting help of map function. Simply connect this function. So now we simply convert the scale factor NDVI and LST, and I want to make the correlation between the NDVI and LST. So this is my main purpose. So now for mesh NDVI and LST by date. Okay, by date we just simply mesh by date. So this is the third step, we simply write the comment. So it's a mesh NDVI and LST by date. Okay, so in this case we just use here, okay, just take a join, just take a variable suppose joint and apply ee dot join dot inner. Okay, if you check this function how it will be work, simply search here ee dot join dot inner. So you can see this is a join function, this is a join function. So it returns a join that pair elements from a primary collection. Okay, from a primary collection with missing element from the secondary collection. So I have a two collection, NDVI collection and LST collection. So just we simply apply the e join dot inner, and then we can get the primary key. Primary key basically, if you check the property name used to the same shape to the primary mesh. Okay, and secondary key basically suppose NDVI and LST. So two key we have. So we simply mash these two element at the same time, or two variable, and you can see measure get optional or null we just use. So now we simply define, suppose this e dot inner I want to apply. So just apply, and if you check what the function for, what the argument, apply, yeah, you can see apply primary data, secondary and condition. Okay, so primary, suppose this is a two variable, join two collection. So I want to join suppose NDVI and LST. So suppose primary for NDVI and secondary for LST. So I simply choose NDVI and LST and then set the condition. Okay, so let's go try to set the condition. So call the primary, suppose NDVI. So this is my one collection, and also put the secondary. So this is the LST. So this is another connection. And now condition, we set the condition how it will connect the two different variable. So if you check the two different variable, so for the just condition, so we filter equal, suppose ee dot filter dot equals and now we define here left field system time start and also another one for right field, same system time start. So we just put this condition left field and right field start from system time start. So now after just we intend to check what happened, just print the joint NDVI and LST. So you find out the property system is global. You find out the primary image is unknown bands. Okay, make sure the image is unknown bands. Why? Let me check what happened. It's not work, just a minute. I think some problem. It show the image unknown bands. So we put the, we select the bands. This is the band for LST, this is the band for NDVI. It is stored in this variable. There is no problem. And then we simply connect and also connect with that. Okay, system time start. So we define it from left field, it will start system time start. Okay, so I think now it's not need. Now let's check. Left field and right field. So this is the NDVI LST. We just put the E filter equals system time and right field system time story. Everything is okay. What's the happen? So we take the NDVI collection from the Modis AY. This is the time 2021. Okay. And then we take the data for LST. Oh, sorry, we make the one mistake in here. I just keep the same snippet ID. So it's that's why there is no basic ones. Okay, so it's a Modis LST. Okay, let me just change it. This one. Like copy. Oh, that's a different. It's okay. No, it's okay, no problem. So mode 13A2. This is the mode 11A2. It's okay, no problem. And then we apply the rescaling factor. In the rescaling factor, okay, let me check. After rescaling, what happened for NDVI? Use the how many emails? Oh, it's also okay, there is no problem. And same for LST. After rescaling, what happened? We find out that same. Okay, also there is no problem. So I think this problem something in here. So what's the problem? So this is the join inner function, and then we apply this function. Okay, let me check for apply. Join two collections, so primary, then secondary, then condition. Okay, then we apply the dot filter equals left field and right field will be equal. So dot filter dot equals this one. And now we put it at the left field. Oh, sorry. It also then right field. Okay, we just use the only for field, not value. Hmm. Anyone can guess it? What is the problem in here? Why it's not working? System. System time start. Just let me my previous code. Let me check. Let me just copy from the same line of code. This is the LST. This is the NDVI. So now it's worked. Okay, so I can explain what has happened. So this is the image collection. We find out it's a modis NDVI and filter bounds and also take the filter date. Then same process is the LST. We choose the band LST to 1 kilometer. Then we simply convert the scale factor. We convert the scale factor. Then this is the LST also convert the scale factor. Okay. And then we simply use the inner function join.inner and apply the NDVI and LST. NDVI and LST. And then condition we set system time start and also right field and left field similar. So now what happened, you can check. I think some mistake for the spelling or others. I don't know what is the problem. Just I use the same, just copy and paste. It also worked. Okay, now if you check, just click on here. So we find out the 23 features, and you can see we find out this type of result. So from the properties, it show the result for primary and secondary. So basically, it's just make the merge between two bands. Okay, between two bands NDVI and LST by their date. Okay, suppose you can see this is the 1st January 2020. So we find out this is the one for NDVI, this is the another for LST. Second, this is the another for NDVI, this is the another date for LST. So it just create this type of things, just simply merge the two bands NDVI and also LST. So NDVI is the primary, LST is the secondary band. Okay, it says create total for 1 year. We just choose the data for 1 year, so that's why we find out this type of result. Okay, so now it's also work. So now after March, just simply make the mass NDVI and LST by date. So this is the process. Basically, just simply mass NDVI and LST by date. So now we need to merge NDVI and LST bands together. So NDVI and LST bands merge. Okay. So when you merge, we simply use the primary and secondary. These two bands we simply merge together. merge, just store it in one variable. So take the variable name, suppose merged. We can put any name as a variable, and we create a function. Okay, this function help me to merge NDVI and LST and make a one image collection. Suppose NDVI and LST just make the one image and create the one collection. Just combine, just merge NDVI and LST. So for that, it's a image collection. So we define EE dot image collection. So we simply merge NDVI and LST image collection. So just define EE dot image collection. So now create a function. Okay. So we create a function. This function, it just take the NDVI image and LST image, and it return NDVI image connect with LST image. Okay. So we just take a two variable. Suppose one variable for NDVI, another variable for LST, and now we return this both of, just make the connect, just use the add bands, just add these two bands together. So take a variable, suppose NDVI image, and it's a image. So just to put here EE dot image, and this image, okay, and these things, okay, it's not the for only one image. So in this case I have total 23 images. You can see in the feature collection we have total 23 image collection. Okay, so now we create a function. Okay, and we just take the both. You can see for the first image, this first image have the two bands, NDVI and LST. Primary is for NDVI, secondary for LST. So now every image, suppose for the first image, second image, third image, every image I need to just extract the NDVI and LST from every image. So now we need to create a function and then define the variable, because I need to reuse my code. Okay, so just I reuse my function and just I extract the NDVI and LST band from here. So now we create a function. So for the function, just create the function keyword. I put the variable element name, suppose feature. So now what I need, so using this element I extract two band, okay, NDVI and LST. For the first band I take a variable, suppose NDVI image, and it's a image, so put here EE dot image, and this image just I call the feature. It's get from, you can see NDVI image, it's get from primary. Okay, because you can see primary is the NDVI, so it's get from primary. Just we define. Okay, it's done. So now same process, take the another variable, suppose LST image, it's a image, so EE dot image, and this image feature, it's our element name. This image get from secondary, because you can see secondary band is LST, so just I use the secondary. Okay, we use the secondary. So just we create a function. So in this function we just put the feature element, and using this element we simply get the primary and secondary, primary for NDVI, secondary for LST. So now what I return from here, so from this function I want to return, just simply connect, add. So this NDVI image add bands with LST image. So this is my ultimate goal, I want to connect. And further we simply rename it. So just I put here the dot rename, or you can write in here, suppose dot rename. I put the dot rename NDVI, another is for LST, so LST. So just we merge and put the name NDVI and LST. And set system time star, and NDVI image get from system time star. Okay, so now this is our function. Okay, so you can see, so this function we just connect with our this joint, this variable, because you can see when I print this variable, then we find out this type of collection. So this collection have the two bands, so simply we just mark two bands, but this 23 image collection is stored in the join, so just call the join and connect with this function. So just connecting using the map function. Okay, just close the bracket. So now it merged. So now let's check what happened. Just let me print. So you can see it just merged. Okay, so you can see the first image is the two band NDVI-LST. Okay, second image two band NDVI-LST. So simply merge the two bands. But previous time you can see when I join by mass, join by date, mass NDVI-LST by date, so that it will different. It's the different. So you can see it's the different. So just click on here, we find out the properties. So you can see for the first image, primary, secondary. So primary image, we find out that band NDVI. Secondary image, we find out the LST. Okay, but when I apply this function, when we merge, and then two bands make the one bands. If you check one image, so two bands make the one image. So this is the first, we find out the two bands. This second, so we find out the two bands. Okay, so every image create the two bands. So this is the one kind of technique. Suppose I have the different types of image collection, but I want to make the, suppose, statistical or time series chart or different types of analysis I need. So for that we need to just merge. So in this time I just compare NDVI-LST, just I put the two bands. Suppose some analysis we need the more than two band, then we just simply combine three bands or four bands or five bands at the same image. Suppose for the first image three bands or four bands. Okay, by when you do more complex analysis. So in this case we simply work for the NDVI and LST. So for the NDVI-LST, just we simply create the every image two bands. We find out every image have the two bands. So now after when you merge these two bands, so then we can easily compute the different types of things. Suppose I want to compute, suppose average image, compute the average NDVI and LST for the AOI. So for this study area I want to compute what the average LST, what is the average NDVI I want to compute for every image. We try to compute. So let's go try to do it, then check the result, and based on this result we just make the correlation. Okay, suppose every image, what's the average NDVI and what's the average LST for every image in the 1 year, and then after computing this NDVI, average NDVI and average LST for every image, then we compute the correlation using this data and then check the result. Okay, so now we compute, suppose compute average NDVI and LST for AOI, okay, for this study area. So every image, total 23 images we have. So now what can I do for, I want to compute one image, we can easily compute, but now I have total 23 images. So just use the concept of function. We are just create a function. So this function help me to compute all of images, average NDVI and average LST for my study area. So I will reuse my code. So function help me to reuse my code, and then we can easily compute at the same time all of images, average NDVI and average LST. So let's go how we can create a function. So take a variable, suppose this variable I input stats, and now create the function keyword. I put the element name, suppose image. You can put any image element. So now what is my argument? So my argument is that from this image, I want to compute average. So take a variable, suppose mean, you can put it in as a variable, and then call the element image and apply the reduce region function. Okay, so this function a lot of time we already use to compute the different types of statistical value for a specific boundary, reduce region function. Okay, so now we just simply apply all of argument for the reduce region. So first argument, it's called the reducer reducer mean, we compute the average. Then geometry, it's your shapefile. This is AOI. Then scale is the 1000 meter. And then suppose you can also apply the max pixel for the big study area, because it's a big study area. I put suppose max pixels is 1e13. So now this is the function. Okay, we simply just create this function, and what I return from this function. So basically we return a feature from this function. We return the feature. So put here ee.feature, and this feature there is no geometry. Okay, so basically ee.feature, this is the function. This function basically help you to generate different types of geometry with that information. Suppose I have a geometry, suppose I just simply define here let long, okay, any number, then I put the attribute, just make the, suppose this let long name, suppose Bangladesh. So this type of attribute we can simply generate using the ee feature. So basically ee.feature is this function help you to compute or generate the different types of point, line, polygon with their attribute. Okay, but in this time there is no attribute, so for that we simply apply the null function. We just need only for the value. Okay, so after null, simply set here the mean dict. I want to just extract only for this type of value or information from here, and it's set. You put here the set function, set with, we put the time. Okay, time, and also this time basically it's come from the image date. So just put mention here image, this is my element name, image dot date, and date format we also mention. Suppose format, we can set the format year. Okay, then put here the month, and suppose day. So we simply put this type of format. So it create a function. Okay, so now this function help you to compute the average value, and it's return as a feature mainly null feature mainly there is no geometry, it just show only for the value or information for the first, second, third, date wise value. We find out that date format. So this function you need to connect with your collection. So you can see this is my collection merge, just call the merge and connect, just map function, start and it. Okay, so now print and then check what happened. Stats. So you can see show the image collection computing, but now these things we just convert into the other. So you can see what happened for the feature. We find out that this type of feature, so you can see it show the ID, this is the date. Okay, and this is the properties. So you can see for, we find out for this date, we find out that this is the NDVI value average, this is the LST value for average. Okay, so it provides the value or compute the value. Suppose for the first this time what the average NDVI-LST generate, then you can see another time. So for this time what is the NDVI-LST average, we find out in here. So it create the all of images and compute the every date average NDVI and LST, we find out in here. Okay, So now this is the image collection. You can see, find out it show the image collection. So when I run, you can see whatever it show the image collection, but this image collection I have to convert as a feature collection. Okay, so just we convert the feature collection. So how we can convert? So convert to feature collection. Convert to feature collection. So now set here, take a variable, suppose stats fc feature collection, and now put here ee dot feature collection. Okay, and now just call this variable stats. So now it's converted as a feature collection. So now let's check the result. So I print these things, stats fc, copy, and run the code. So now it display, you can see feature collection computing, and if you check the feature collection from the feature, we find out this type of result. But now it works as a feature collection. So why I convert the feature collection? Because when you convert it as a feature collection, then I can easily make the chart. Suppose I want to make the time series chart, this feature. So it's a feature collection. So I can easily make the time series chart as a features, feature by feature function. So if you check the one function, it's called the feature by feature. Simply search here, feature by or chart or chart I think this one, UI chart feature by feature. Yeah, this one, UI chart feature by feature. Okay, so you can see this is the function. So when you convert anything, suppose you have a feature collection. Okay, basically in the feature collection you find out this type of information. It shows the feature. So you can see this type of feature we find out. So any feature you have, so now this feature you can convert as a chart, or you can easily make the time series chart for this feature. So you can see for this feature, I have this type of data, NDVI, LST and time. So I can easily apply this function UI chart dot feature by feature and make the time series chart. So let's try to show you that. Just import this function. So now we simply define all of this one by one. So first argument is the features. So in this time, my feature is stats, this one. I already convert the feature collection, just I define. And now X property and Y property we simply define. So in the X property, we consider it's a NDVI, and Y properties, it's a LST. So we simply put here that LST. And you Y properties, we just keep this type of bracket. X properties don't need this type of bracket. So now for if you want, you can also add some different types of style. Okay, or if you want to display the chart, then I add the style, then you get better idea. So take a variable, suppose chart equal, and print the chart and run this code. So now let's check what happened. We find out this type of chart. Okay, but the chart is not meaningful. How we can easily get, we can check. We find out this is the LST and this is the NDVI. Okay, so now from the chart, how I can generate the correlation information, basically how I can generate this type of chart between two variable, how I can create this type of line. So from this line we can easily get it negative correlation or zero correlation or positive correlation, and as well as we can also compute the R value. You can see negative indicating about the perfect negative correlation, 0 means that there is no correlation, 1 means that indicate the perfect positive correlation, or high positive value is the positive correlation. So this type of things when you generate, then we just apply the trend line analysis. Okay, so let's go try to show you that how we can apply this trend line on the chart. And it also more better without the line chart. If you just convert into dot chart or a scattered chart, then it look more perfect. And then simply apply that trend line or fitted line for the correlation, then it will be look more perfect. So let's go try to add the chart type. Simply change the chart type. So simply search here set chart type. So different types of type. So you can see just I use this function set chart type and apply in here, and I define the scatter chart, this one, and run the code. So now it's create this type of scatter chart, you can see. Okay, so this one is more perfect, looks very good than previous one. So now from here I have this type of data. If you want, you can also download the CSV file, then we can get that this type of things you can see. Just I will show you the chart, then we can get the data. Okay, LST and NDVI data. So you can see this is the NDVI column, this is the LST column. So I have this type of column. So now if you can easily use the different types of Python programming and compute the correlation, different types we can do. But I want to do using the Google Earth engine and also make the chart in the Google Earth engine. So let's go how I can use it and create the correlation chart between the two variables. So for that we simply add set options to add some option on my chart. So first option I want to check, suppose title. I set the title, suppose correlation between NDVI and LST. Okay, so I put at the correlation between NDVI and LST, then apply here horizontal axis, suppose x axis, mainly x level, it's indicating about NDVI, put it, it's a NDVI. Then vertical axis, it's indicating about that LST in degrees Celsius. Then you can also add here, suppose you can also increase, suppose you can see now we find out this type of point. If you want, you can also increase the point size or decrease the point size. So for that, simply use add the point size option. So point size. Suppose I put at the point size is 5. Okay. And now apply the trend lines. Okay, trend lines for the first. Basically, it's only for the one chart. So just I put the first and behind. Suppose I put the color. It's a suppose I put the red color. Now let's check run the code. Why is the trend line? I think we need to apply the type. Suppose I put the type is the linear. What's wrong? Friends, we just add. Oh, sorry, lines. So now you find out. So now this trend line, we just simply add. Suppose I put the color. Color is suppose red. Okay, so we find out this type of trend line. So from this trend line, we can easily get the idea. It's a negative correlation. Negative correlation means that if the NDVI value is high, then we find out the low LST value. Okay. If the LST value is high, then we find out the high NDVI value, high LST value. Okay. If the NDVI value is low, we find out the high LST value. Okay. If the NDVI is high, then we find out the low LST value. So from that, we can easily get the idea. It's a negative correlation between NDVI and LST. Okay, because if the LST value is high, then NDVI value is low, and if the NDVI value is high, then LST value is low. You can see. So the NDVI value is high, then we find out the LST is the low. But when the NDVI value is low, then we find out the LST value is high. So now we find out the negative correlation. But this negative correlation, we can also generate this type of R value, okay, or R square value. We can also generate from here, and from the R value or R square value, we can get the idea what's the value, how many correlation. If you check, correlation can be different types of correlation. We find out, suppose a strong correlation, then you can see the perfect, strong, moderate, or weak. You can see when it show the result for not much high, low positive value, it's a weak, then moderate, then strong, then perfect. So different types of correlation we can also generate, same as for negative correlation also. So let's try to calculate the value of R square value or R value. We try to compute. So for that, you can simply apply the another argument. It's called the show R square. Okay, and then apply the true function. So now run the code. So now it display the R value also. Where is it? Why it not showing? Show. Okay, as well as also open another argument. It's called the visible in legend true. Yes, so I hope now it's showing. Yeah, so you can see, find out. Yes, please.
The R value and the level of confidence, how are they related? Normally, they say the confidence level is 90, 65, 95. How are they related?
Which one? Which one? No, understand.
Normally, they say they report this. They say the confidence level is 90, 95. So how are they different from the R value?
This one, yeah.
So the confidence level, they will say the level of confidence they normally report in this report.
Oh, yeah, yeah, understand. Yeah. Confidence level. Okay, so confidence level basically generate from the alpha value. Okay, alpha value. I will explain also about that. No problem. No problem. I try to explain. So you can see this is it create one kinds of linear relation. I can see we find out the y equal to mx plus c. Okay, mx plus c. And here you can see always the m value and c value is different. Okay, m value and c value is the same for any point. We find out the m value and c value different. We find out the same. And you can see it show the negative slope, basically minus 1425.237. it's a negative slope. Okay, it's a negative slope. So that's why you find out this type of curve or this type of line chart we find out in here. Okay, so this is the visualization of correlation chart, but I want to visualize it in my map. Suppose I want to identify geospatial displays have the more highly negative correlation. This place is the positive correlation. So this type of correlation I want to visualize on my map. So let's try to show you that how we can easily visualize this type of correlation map and identify which place have the high negative correlation. This type of thing we can generate from the correlation. Okay, correlation map. So now we try to create the correlation map, NDVI and LST correlation map, correlation map. So for that, suppose I want to display suppose NDVI and LST map first, then show the correlation map. So for the NDVI LST map, just take a variable, suppose NDVI, and we already make the collection. You can see, just I call this NDVI, and I create suppose mean, and click with my study area, which is ROAOI. So same process, take a variable LST dot mean, just use at the clip with AOI. So now you can easily visualize the map dot layer for NDVI. Okay. So now add the color. And now if you add the color, then you can get the more better map for this study area. Just click. And add the color. So I just add this type of color. Oh, just a minute. we find out this type of map for NDVI. So now same for, we check the LST color. So again, we find out this type of map for NDVI and this type of map for LST. So basically this type of place indicating about the high temperature, okay, for LST. And if you check where there is low, NDVI is high, so this type of place we find out the high. Also this type of place is the NDVI, you find out, okay, we find out that, okay, so we find out this type of place is not mass. Also this type of place we find out that. So now I want to make the correlation and identify for high correlation and low correlation this type of map. So for that, we just we call this, that is the correlation. So for the correlation, we find out the different types of correlation. Suppose I want to identify Pearson correlation. Okay, if you check, simply search here. We already know about the Pearson correlation. Just simply search here Pearson correlation. So we find out, you can see p-value. So now from the p-value test, we can get that your level of confidence, this type of information from this function. So it's show the result, compute input into the reducer that compute the Pearson product, moment, correlation, coefficient, and two-sided p-value test for we find out, okay, this type of things. So this is the correlation. So I want to apply this correlation on my data set, this function. So take a variable, suppose I put the variable name is for, and now call the merged and select the two band between NDVI and also LST. Okay, basically you can say I already defined the variable name is merged. Yeah, this one, basically where I join, and I rename it as the NDVI and LST. Okay, just I simply call this one and then put here NDVI and LST and apply, and I put here that reduce. How I can reduce? ee.reducer.Pearson correlation. So now we try to check the Pearson correlation value. This map. I just run the. So we find out, you can see, we find out that correlation it generates the bands for the correlation and also p-value. So this correlation we can simply display on our map, because you can see it's an image and this image have a two bands. So I want to display suppose a level of confidence. You can also display suppose level of correlation. So this type of things you can simply display in here. Suppose take a variable correlation and then call this core. From here just select this band name correlation and clip suppose with the study area of uses AOI. So now display correlation and run the code. We find out this type of available check. And if you want to also add the color to identify. Suppose this correlation is simply stressing 98%. Suppose I put here that negative correlation. Okay, so this type of place I want to display this type of blue color, negative correlation. Then suppose I want to show this type of green color, then this type of white color, yellow color, and positive I want to show this type of color. So now apply. So now I can see here we find out that this map, and this map represent the correlation map, okay, between NDVI and LST. And we find out that this type of blue color indicating about the negative correlation. Okay, this type of blue color, negative correlation means that if the NDVI is high, LST is low. So this type of place we find out this type of correlation. So it's a negative correlation place. And this type of yellow, this type of red color indicating about that you can see it's the high correlation value. Okay, we find out the high correlation value or positive. So if the increase, then it also increase. So high, we find out this type of place. But negative correlation is high for this type of place. Then it increase, individual increase, gradually increase the correlation value. So this is the one kind of correlation map. So different research paper, we need to add the correlation and also identify for the correlation map and also correlation value. Okay, for the different time period, you also check a lot of paper is available for the identify correlation between. Suppose this correlation you can also add for the also precipitation. Suppose make the correlation between NDVI and precipitation. So for that, first of all, simply make the map for precipitation and also make the map for suppose an NDVI. Suppose precipitation NDVI. So simply you can use the precipitation and NDVI, make the correlation. Suppose you want to make the air pollution, you can also connect with the correlation. Suppose you just try to add for the forest fire area and also make the correlation between the forest fire area and suppose air pollution, then make the correlation. Suppose there is another example, then you can get the better idea. Suppose for the air pollution, how it will work. the burn area. So for suppose for this burn area, for the correlation for the air pollution, different types of parameter. Wait a minute. Check. Check one. So this is another correlation between the chlorophyll and temperature. Okay, for the it also help you to for the water quality monitoring also. Okay, if you check. So you can see we find out this type of chart. It display the temperature and chlorophyll. So if the temperature is high, then chlorophyll is also high. Okay, for our study area we find out for that. Okay, so this is another correlation we can also generate. Suppose chlorophyll and temperature and identify the correlation between the chlorophyll and temperature. So from this analysis we find out that if the temperature is high, then chlorophyll is also high for this type of place. There are a lot of things we can do for the this type of analysis. Same process. Okay, so you also try this type of any other correlation if you need further for any research paper. Okay, then you can also inform me. I will try to suggest. But same process you also try and make the correlation. Okay, to identify positive correlation, negative correlation, this type of thing. We can easily just apply the same process to identify. Okay, and you can see not only for the correlation. If you want, you can also identify for also p-value. Okay, so p-value, just simply work with the p-value. Just copy level of confidence. Just a minute. Okay, so now suppose I want to work with suppose p-value, and from the p-value we can also compute the confidence level map. Okay, it also possible to from the p-value we can also compute. So what the relation between the p-value and the level of confidence level? Suppose from the p-value from p-value we can also compute the confidence level. Suppose confidence level map, this formula basically 1 minus p-value. Okay. So this is the confidence level 1 minus p-value. it output, basically we just already compute the correlation between the two NDVI and LST. Okay, and we also compute the Pearson correlation. So basically this function, when you compute, it provide you the two output. Okay, one output for the correlation, another output for the p-value. Okay, so from the p-value we can also generate the level of confidence. So when you need the level of confidence map, then just apply the 1 minus p-value, just simply subtract this p-value, then you can get it, confidence level we can generate. So for that I will show you that how it will work. Suppose I take a variable, for r, it is suppose correlation. So just I call the this one, paste here, and select the band. This band name is correlation. Yes, we already know about that correlation. We can also display the map of correlation. Then take another variable, suppose p, then call the variable and select the band of p-value. P-value will define. Then another one is the level of confidence. So suppose take the variable so C for level of confidence, or LC or CL, confidence level. Okay, and now 1 minus, so EE dot image 1, this subtract with this P. So we simply compute the this thing also. So now I understand, so I print. So print CL and check the result. So now it create the level of confidence one image. We find out it is the level of confidence image. Okay. So now from here we choose, suppose only show suppose less than equal 0.05. Okay, I want to display suppose 95% confidence level. I want to display suppose 95% confidence level map. Suppose 95% confidence map. So for the p-value will be your p-value less than equal 0.05. Okay, so when I get the value, p-value will be less than equal 0.05, then confidence level will be 95%. Okay, so now from here just simply set so let's take a variable a variant, suppose suppose 95% confidence 95. I put any variable, this type variable I just put. So now just call the p-value, just call the p-value. Okay, from the p-value we set less than equal 0.05. 0.05 is indicating about the 95%. So now basically it show the result correlation value. Okay, so only show R where P less than equal 0.05. Okay, so basically these are main target. So we only show the R, basically your relation R map or correlation map where confidence level 95%. So confidence level 95% means that p value less than equal 0.05. Okay, so let's now we try to display the R again. So take a variable or directly try to visualize, suppose map.add layer. just call the R. Okay, this R, I want only show the R where p value 0.005. So just I call it just it's a R and apply the update max function. Okay. Update max function using this condition. Okay, this condition it will write on the upper of the code. Okay, this condition. So now this R map is display only show the 95% confidence map. Okay, so now check the result. So we find out, okay, need to just put here clip function, clip with AOI. So now it display the R correlation 95% confidence level map. We find out this type of place. So let's go try to add the so now again add the confidence level. Suppose low value indicating about that weak, very weak or insignificant. Okay, then weak, then moderate, strong, or very strong. Okay, suppose I just put this type of color for the very weak or insignificant level. Then suppose weak, I put the weak, suppose this type of color. Then suppose I put the moderate, just put this type of color. Then strong, put this type of color, and very strong or 99% confidence level, very strong, I put here suppose this type of. So now just apply. So now let's check for the visualization. So now we find out the confidence level map, this type of map we find out. So this type of place we find out that high confidence level, okay, very strong confidence level. Okay, from the R value we generate this type of confidence level, help of R and P value. Okay, so only show the R, P value where 0.05%. So now it show the confidence level 5 or 95% confidence level. We find out suppose this type of place is very high confidence level, 95% confidence level. This type of place is very high, but this type of place confidence level is very low. We find out that. So further simply export this type of map, and you can also work with art map or QGIS software to make the classification for your research paper, or that's it also possible to do this type of work. Okay, any question you can ask me, please. Yes, please.
So for the previous analysis we have done, the NDVI or 10, this is the kind of confidence we have to do on those papers, right?
Yes, so you can convert this type of things, just apply the confidence level. Basically same, just simply call the p value, okay, previous analysis, and display the confidence level. Okay, different confidence levels, about 0.05. You can also take the 0.01, then 99% confidence level, then you can find out. So this type of thing just simply to get the more better research paper or present for we can easily submit for the high journal when you add this type of information. Okay, so basically you just make the classification. Okay, suppose define the confidence level from R value. We simply add the different types of classification. Suppose simply make the classification. Suppose if the value, suppose 0.2, 0.2, then we simply say that it's a very weak. Okay, confidence level is very weak. Can if confidence level very weak means that it's a insignificant. Yeah. Okay, then suppose 0.2 to 0.4. Okay, suppose its confidence level it weak. Okay, so weak basically we can consider as a 80%. Okay, confidence level. Then suppose 0.4 to 0.6, so we consider it as a moderate maximum paper. They are used the moderate basically 90% confidence level. Then if the R value 0.6 to 0.8, it show the strong. Strong basically 95% confidence level, 95%. And this type of confidence level you can also generate. Okay, just apply the same process to generate the different types of confidence level map. It also possible, and further export. And finally suppose greater than 0.8. Okay, basically it's R value or R range, and further we can simply apply this type of interpretation for this R range and also alpha value or confidence level value. Okay, then finally suppose very strong, it's confidence level 99%. Okay, so you can simply download this type of map and also make this type of classification. Further you can also add, then it will be more better analysis for the confidence level with the correlation analysis. Okay, so help of Pearson correlation. Okay, so also try further place any problem, so guide you. Okay, so this is the way we can also apply the different way. So basically it just show only for the one study area, suppose only for the whole country boundary of Saudi Arabia. But if you want, you can also do it for this small study area. Okay, and also make the correlation, then it will be provide the more better result for the correlation others. Okay, but when you work with the small study area, try to use the Landsat sensor, because Landsat is more high resolution you find out. Okay, so now we talk about another topic. I hope this topic is you can understand about that how it will work. So also try to other sensor, then face any problem and also guide you, no problem. So now we talk about that LST. Yes, please, question, please. Yeah, please.
Yeah, so which Landsat that we actually use for these kind of correlations? 5 to 8, 9, or?
Okay, so basically for this same process, suppose when you work with, so in this case I just take for the 1 year, but when you make the correlation, then try to use a different year, okay, or multiple year. So then I hope it also better. So we already know about that how we can easily merge our Landsat 5, 7, 8, 9. So you can use this type of data and make the analysis. It will be more better, okay, for the correlation. Again, when you make the correlation, try to use the 10 years or 20 years data. So then this result will be more effective for when you take the long time series data.
Okay, so the kind of image composite collection created during the trend analysis, you can use that one here better, right?
Yes.
Okay, I wanted to ask about you. Maybe we're using multiple years. Maybe when, let's say, you want to find how surface temperature affected NDVI over the years. Can you do that here?
Yes,
Is it possible?
Yes, it also possible. So these things, okay, so basically we just use the Landsat. We have already known about that image collection, different types of Landsat image collection. Okay, we need to merge Landsat 5, 7, 8. So this same thing, suppose in this case I just take the MODIS data. Okay, So this code simply convert into Lancet. Okay, help of all of Lancet parts simply make the annual collection. Suppose 1992 2025. So we can make the every year LST, every year NDVI. Just make the collection of every year LST and every year NDVI, and further simply apply the same procedure to make the analysis. Okay, for the correlation when you work with the multiple year combined. Suppose you just take the suppose total 36 years data, or 36 years NDVI and LST data you have for any specific area. So just make the collection 36 years LST collection and 36-year NDVI collection. Just make, and other procedure just simply apply the same process. Okay, so in this case we are just take only for the 1 year. You can say only for the 1 year collection, only for the 1 year collection. So these same things which need to convert into Lancet. For just use the Lancet, because we already discussed about that how to make the Lancet LST time series, annual time series, or LST NDVI time series. So this type thing already covered. So just from the Lancet we just take the data, suppose 36 years NDVI data or 36-year LST data, and then make the analysis. So you start, further face any problem then I also guide you, no problem. So you start the this type of analysis using the Lancet. Further face any problem, inshallah I will guide you, then you can easily get the solution, no problem. Okay, but procedure is the same. Just we need to take our time series data, suppose annual time series data for NDVI and annual time series data of LST, then we can easily make this type of analysis. Okay, I hope you can get the idea. So you try first, okay, then face any problem I'll also guide you, no problem.
Thank you.
Okay, thank you. Okay, so now we talk about the another topic. Basically, suppose we already know about the some machine learning work on Google Earth Engine, but it also possible to use the Python, different types of programming language to make the more deep analysis for the land use land cover classification. So I will show you this process also how we can easily work. So for that, okay, so I have already previous code, but I think it is also complex when I show you the only for the code. Okay, so let me just explain the code one by one, or rewrite the code again, then you can get the better idea. So let me open the code editor. We just open a new notebook. Okay, so first of all, simply import some library. So this type of library basically in Google Colab, Rasterio or GeoPandas or Gradient Boost, it's one kind of machine learning algorithm. So this type of algorithm is not installed at sometime. So we just install it, this type of library. Mm, just a minute. Okay, just simply paste and install it. So simply install it, this type of library successfully install it, then there is no problem. Yeah, so then just call some library we need to import again our code editor. Suppose we need to import one library, it's called just import suppose a rasterio, then import another library, it's called uh, rasterio dot plot import show, then import. I think it's a better I just explain one by one, and then I also show you that use of this type of library. Okay, not at the same time not in import all of library, then you can get the some not idea. So first of all, how I can make the analysis. So first of all, we need to import a satellite image. Okay, it can be Landsat, Sentinel, or any high resolution imagery you can use, no problem. So here I already import the satellite image in my um, Google Drive. So I simply mounting this drive and connect with the Google Drive. So here I use the Sentinel-2 satellite imagery. So combine all of images, all of bands. Okay, so it is stored in my drive. So let me open from here. So my drive, in the my drive, it is stored in one folder. My folder name is Visa. And this one. So here we find out the one image. It's this image basically I downloaded. So this is the Dhaka city images. Just I simply copy the path and store it in a variable. Suppose I put the variable name is that path image. Okay, and then paste the path. So this is my image path. Okay, so simply import it, there is no problem. Okay, so first of all, this image I need to visualize in my collab. So for the visualization in Python, where use a package, this package name is rasterio. Okay, so rasterio package mainly help you to read the raster image or raster data. Not only for that, any raster image or tip image you can easily visualize or read the information or display mainly matplotlib. So just simply import that one library, because this library I need for visualize my image. Okay, but if you want, you can also at the same time you can also import all of library, but I just explain first time, so that's why I simply show you the work and then import this type of library. Suppose I just import rasterio library and then also import rasterio as, so rasterio plot import show. Okay. So these two library I simply import in here. Sorry, it's a from. Okay, so from the rasterio plot we simply put the show. Basically it display the image or other things to display. So now run it. So there is no problem. So now I stored my image in here, and now I want to display the image help of rasterio. Okay, I want to read the image. So for that I want to open this image. So take a variable suppose src and then call the package rasterio, and then you that open this path of image. Just I define this, I want to open this image, so just I put the open function. It's come from this package and stored it in this variable. Just I open this image, so run the code. Okay, so we find out this type of result. There is no problem. So now if you check some information, suppose if you want, you can also check the number of bands, how many bands are available in this image. So src is stored, so I want to check number of bands. Suppose number of bands. So for that, just call the src dot count function. So now run the code. We find out that this image have total 12 bands. Okay, suppose this is the one information you can get from here. Not only for the, you can check suppose special extent. Okay, a special extent we try to check. So just call the src dot bounds. So now it show about that special extent, mainly your area, special extent area. Oh, sorry, that's it, bounds. So we find out, you can see this is the special extent area. We find out left, bottom, right, top. Okay, not only for that, a lot of info you can find out. Suppose I want to check suppose coordinate system or crs of my image. So call the src, it stored my image and apply the crs. So now it check the result for coordinate okay, coordinate reference or coordinate system. Okay, so now run the code. So you can see we find out that wgs 984. Okay, now we can also check suppose resolution of my image. So for that, just src dot res resolution we find out. So this is the x and y column we find out in here, x and y. Okay, and also check suppose metadata. So src dot meta data, or src, it's called the profile. Okay, profile, it show the metadata, image metadata. So metadata we want to check. So you find out this type of metadata, you can see. Okay, then also, okay, so this type of information is needed for that. And I just call the src and run. So you find out this is the directory of my image. Okay, and I want to check the shape of my image. Suppose src, or I want to read the image. Suppose src dot read. Okay, so after open, so you can see after open, I just use the open function in here. So after open this image, I want to read the information of this image. So simply apply here src dot read and run the code. So now it's give me all of value. Okay, finally you can see this type of array. Okay, suppose I want to read the image and store it img variable. Okay, so now img variable is stored this information. So now I want to check the image shape. Okay, image shape, it's a 2D or 3D. We want to check 3D array, 3D numpy array or 3D. So for that, just apply the function. It's called the, suppose it is stored in variable img. Just I call the img and apply the function. It's called the shape and run the code. We find out this type of shape, we can see. So this shape we find out it's a 3D array. Okay, it's a 3D numpy array with shape. So first it indicating about that first shape, it show the bands information, bands. Second information, it's called the rows. Third information, it's called the columns. So how many column, how many row, how many bands in your image, we find out from here. Okay, then we check image shape. And if you check the type, suppose print, I want to print the type of image and run the code. So you find out this type of numpy class or array type. Okay, type of the image is array. Mainly it is a 3D array. We find out in here. Suppose I want to read some band from here. So for the how I can read the individual band, it's a total 12 bands. Suppose I just need only for the first band or second band I want to display on my map. So how I can display for that? Suppose I take a variable band 1 and I call the src dot read. Now it read only for the first band. Okay, when I put the read 1, it just read only for the first band. So now run the code. And this first band I want to display on my map. So how I can display? So for the display I need to import a library. This library called the matplotlib library. We can also import. Okay. So let's try to import the library. Import matplot library as plt. I just simply import this library. So I want to visualize this band 1. So that's the reason I need this library. So now call the plt dot imshow. Matplotlib is simply call the imshow function and call the band 1. Okay. And call the plt again, plt.show, and now run the code. Yeah, so you find out this type of bands. Okay, this is the first band. First band basically I think it's a blue. Okay, suppose you want to check suppose second band, same process. If you want, you can also add the suppose different types of suppose I put the cmap equal gray. I put the gray color of my band. So cmap equal to gray and run the code. So now it display the gray color. Okay, gray color view. You find out. You can also add the title. Suppose I want to add the title. So plt dot title and put the title suppose band 1 and run the code. So it show the title band 1. You can see if I know. Suppose then display the band 2. So simply change it src read suppose 2 and run the code. So now it display the band 2. Okay, this is the band 2. We find out in here. So this is the band visualization process. So now I want to combine. Okay, suppose I want to make the band combination. Okay, band combination, how I can make the band combination. So let's go and visualize the different types of natural color or also false color, this type of thing. So for that I call the img dot shape. So this is the shape of my image. Okay, this shape I need to change. So it show the result bands. Okay, it show the result for bands, then show the result for rows and columns. Okay, columns. So this shape I need to change. I need to convert into another range. So basically bands, this is the serial number 0, then it show the 1, it show the 2. Okay, 0 1 2. So this serial I need to change. So I put the transpose. So I put the variable img equal, and if I just call the img dot transpose, I want to change the serial number. Suppose I want to display, first I want to display the row, then column, then band. Okay, suppose I want to display first 1, then display 2 column, then display 0 mainly bands. So now this shape is the change, but we face a problem and show that. Okay, so we need to import the one function. It's called the transpose function or transpose. We need to apply in here. Or let me just import all of function. Suppose just I copy from here and just import all of library we need. Okay, otherwise it takes the problem. Okay, just I import all of library. Okay, now I will work. What is the problem? It show the type error. Oh, sorry. We need to make the bracket. This function bracket we need to define. Okay, then we define this serial number. Yeah, so that's right. So now I check the image.shape. Now I can see what happened. Check the shape again. So now I can see it change. So first it show the result for okay. So now I can see first it show the result for rows, then show the column and show the bands. Okay. So now I simply use the transpose function. It's mainly help you to rearrange the serial. So first of all, its default show the bands, then show the rows, then show the column. But when I apply the transpose and put the first serial is the row, second serial is the column, third serial is the band. So then we find out this type of shape of the image. So it's neat because I need to make the composite. Okay, I need to make the composite. So for that, just I take a variable, suppose red, and I put here call the img. From the img, first column is blank, just only for the colon. Second column is the blank colon, and put the band number. So because 3 number serial is the band, so I simply call the band 3. Okay, for the red. Then put the another, suppose green. Just call the img, and I define first band is blank, then second band, and third band I put the band number 2 for green. Then I put here blue. Just call the img. I put here this blank. Basically, first step is for row, then second step is for column, third step is the for band. So I simply put the band 3, band 2, and I put here the band 1. Okay, so now run the code. So now we destroyed the different types of band, and I want to make the composite using this band. So call that RGB, I call, and then call the, I need the numpy. So you can say I already imported the np mainly numpy, np dot ds tag. Okay, and I have to create the ds tag using red, then green and blue, using this 3 band. So now run the code. So now it create the RGB I want to display. So plt dot figure, I just simply put the fixed size. I define suppose 20. I define the figure size, fixed size, and then I want to display plt dot I am sure, and call the RGB, and also plt axis, and don't need any axis. I simply put here that op. So when I put the op, axis is not showing, x and y axis not showing, just display only for the image. So now run the code. Okay, so you can see this image display but not look more better. So it shows some dark, okay, or darkish. So now how I can make the more better image? Okay, so for that you can just simply multiply. Suppose this RGB just increase the reflectance value or stressing, which we call the stressing in Google Earth Engine. So just put here multiple and put here the, I put suppose 4. So now let's check what happened. Okay, so now you can see this image is now more brighter, we find out. Okay, so this is the way how we can easily display the image, help of Python. Because I hope you can also get the idea. You also try for your own study area. How not only for this Landsat Sentinel, any satellite image or any drone image, TIFF format, mainly TIFF format, any TIFF format image we can visualize. So now this TIFF format image, I want to make classification. Okay, so how I can make the classification? For the classification, first of all, supervised, unsupervised. We already know about the supervised or unsupervised, this type of things. So we need to training sample. Okay, we need to training sample, and this training sample, how I can generate? So this training sample we can generate in Google Earth Engine, or if you want, you can also use the ArcMap or QGIS software. Basically, training sample is stored the band pixel value for per class. So I already created a training sample, so I'll show you that from my side, then get the better idea. Suppose this training sample is stored, okay, this one, okay, SSP. So this training sample I just convert as a shape file, okay, or point shape file. So just I copy path and put the variable name, suppose samples, and then I want to read this file. So it's a shape file. So for shape file, we just simply call the GeoPandas, because GeoPandas help you to, I just add it. GeoPandas show you the result for shape file. Not only for the shape file, if you have the CSV file also, we can also show. CSV file, we need the latitude, longitude, then class, and also need all of property, mainly band pixel value. So in this case, I simply define my path. So this is my path and run it. Okay. So now I read it. So just call the, so for the read, take a variable, suppose I put the same variable, suppose samples, and call the GPD. GPD, what is the GPD? GPD basically it's come from GeoPandas. If you check, where is the GeoPandas? I already defined the GeoPandas as GPD. So just I call the GPD. GPD mainly GeoPandas. So GPD dot read file, read file, and I have to read this file which is stored in this variable. So now run the code. So now it read the full file. Just I call the variable name samples and run it. Okay, so you can see. So we find out this type of file. So here you can see this is my B1, B2, B3, B4, B5, B6, B7, B8, B9, B8A, B9, then B11, B12. Okay. Also you can see the sample water body, barren land. Okay, so different types of sample we simply add it. And how I can get this type of sample, I'll show you that, then you can get the better idea. So I hope you already know about that, how we can take the training sample, same process. Okay, just turn it. Okay, so you find out this type of training sample with their label. Suppose this is my training sample. So I want to use this training sample and make the classification of different types of land use, land cover, help of Python. Okay. So let's go ahead to show you this process also. So first of all, this coordinate I need to convert into coordinate reference system. Okay, I just put the same coordinate reference system. Suppose sample and image. Okay, sample and image keep the same CRS or coordinate reference system, otherwise it takes some problem. So I have a already sample and I already have the image. So this image and sample must keep the same CRS. Okay. So for that, just put the samples. I put a variable of samples equal. Just call the samples because this variable is stored my all CSV file, and put the two CRS function, two CRS. I put the value EPHG. So for my study area 4326. So I simply convert, but it shows a problem. This problem is geodata frame object has no attribute to CSR. So CRS, sorry, CRS. It is CRS. Okay, that's what, no problem. So same, we also put suppose. So now print the samples dot CRS. We try to check again. These are CRS for the sample, and also print SRC. This is our image CRS. Okay, SRC basically stored our image. So you can see image and samples keep the same coordinate reference system, or coordinate reference value we find out. And then suppose this type of sample I want to overlay in my map. Suppose in my map I want to overlay all of sample I want to overlay on my map. So it is not possible. So let's try to show you that how we can easily make the overlay. So for that, just make a color list. Suppose CMap, I want to add the color. Just make the list of color. So suppose yellow. Then put here the red point color. I simply define. Then green. Then blue. I simply define the color. And I want to put here the big. And I have to plot, call the plt dot sub plots. I put the fixed size. And we want to plot the sample. So okay, just I call the column equal. I just call the column class of column. You can see the column. What is the column? Column basically your class level, class column. So class, where is it? The class, yeah, this one. It is stored the different types of class, water or others. Okay. And then put the categorical, just put the true, categorical. And put the CMap equal CMap. Put the legend equal to true. So now let's check what happened. Let me just display the chart. Okay, CMAP legend we simply set legend is true. Okay, then also put the legend. Okay, so just define the legend. It's not mandatory, but when you display the all of point on your satellite data, all of training sample. Okay, I will just show you that legend. Okay, put here B box. We create a box all of legend to display PB box to anchor. And we define that one. Basically, this is the size of the legend. Legend position. Legend position 1.5 we set. And put here lock. We lock it in the upper left. Suppose upper left. We set it upper left. You can also define the font size. Suppose comma use the font size. I define the font size about 16. Font size 16. And also put suppose another environment is called the now just simply display a axis x dot axis put here up. So now let's check what happened. Oh my god. Okay, then we put here suppose show the RGB dot transpose 201 multiply with 4 to bright inference and put here the transform CRS transform AX equal to X. So now let's check what happened. Run the code. List unshareable type list. Okay. What is the problem? RGB transpose. Just a minute, let me copy, check my previous code. What happened? So now if you check, we find out this type of point. Okay, and it also show the some sidebar and the legend. You can see find out this type of legend, barrel land, build up, water body. So this type of things we can also find out in here. So let me decrease the size. Suppose I put at the size is 20. I think it will be more perfect size. Or they find out, you can see this type of things. This is the barrel land, this type of yellow color. We find out it's a barrel land training sample, then water body, then vegetation, okay, and also build up this type of red color. Okay, so this is the process to working with Python. So this is the process for data set. We need to prepare our data set. So after that, we simply apply the machine learning. So this part, inshallah, I show you the further next class, because in this part I will also need to cover the another topic. It's called the your prediction of LST. Okay, so how we can really predict LST using machine learning. I will try to explain about that. Okay, any question in this part, you can ask me please for that. Any question to prepare the data set. So you also try to prepare for your own study area and also display. Yeah, please.
So this one we are doing, you cannot do this one in Google Earth Engine except in the Python here.
The Python, basically we can also use the Google Earth Engine, no problem. But Python is the more advanced. Okay, but you can do the Python, no problem. Using the Google Earth Engine, there is no problem. Okay, there is no problem. Okay.